All right. Thank you very much, ladies and gentlemen, for your attendance. My name is Duduba. I'm a PhD student at Charles University here in Czech Republic, Prague. My PhD deals with machine learning approaches in the modeling of hierarchical extremes. This paper we are about to publish is actually a continuity of my MSc research, where I studied environmental modeling and dealing mainly with hierarchical models. So it's entitled Modeling of Changes in Hierarchical Balance in the Gambia River Basin using Lambda Models. The study investigated the calibration performance of hierarchical models using the generalized split sample test, testing all potential combination of calibration validation periods using Lambda model, BLAN, and GR2N model over a set of 6 catchment of the Gambia River Basin. A subperiod was selected based on the specific climate characteristic, which can be precipitation, temperature, runoff, and a 7-year sliding window. The objectives of this research are to crash test BLAN and GR2 models, and we would like to answer to the question if the simulation period width affects the calibration performance, how well the model simulate the route type, and which of the selected model has better performance, and we will also diagnose the parameters transferability. Figure 1 depicts the DEM of the 6 subcatchments of our study area. So we can see that the Gambia River Basin is located between Senegal, Gambia, the two Guinea, and Malia. The biggest catchment has is about 42,000 kilometers square area, and the outlet is here at Galumbu. So the yellow dots stand for the outlet, and the red dots are the rain gauges. So the mean annual rainfall ranges from 80 to about 200 millimeter. And right here, the mean annual runoff ranges from 8 to about 35. Here we are presenting the schema or diagrams of the Bilan model left side and the GRTM model right side. So we can see that the Bilan model is a 7 parameterized model and the GRTM is a 2 parameterized model. We will use the methodology of generation of subperiod. So here we have a 5-year sliding window, an example adapted from Corona and Bulma. So we can here the red cells stand for the warm-up period, and the 5 cells are the actual calibration period. So we use the 7-year record, and we are doing some the sliding window after 2 years, 3 years, 5 years, 7 years, and so on. So here we can see how the window is shifting, and these are the validation period, like results. Here is the box plot of the overall calibration performance of Bilan model. Using KGE, the Klein-Gupta efficiency, we assessing the model performance. So P stands here for the precipitation, as R the runoff and T the temperature. So D is the record selected on the dry years, and here W stands for the wet years, and L is the lowest temperature and H the highest. So we can see a calibration performance that decreases clearly when the simulation period width is increased. Similar result we have with the GR2 model. When diagnosing the validation performance, so we can see clearly that it's not very easy to say, but the model are quite competing. You know, we cannot clearly state which model performs better, but we can see for some records that the Bilan model can perform better, and for some the GR2M is performing better. So here we have the hydrograph, and we can see here in the hydrograph that the GR2M model has tendency to overestimate or underestimate the simulated runoff. Yes, sorry. Yeah, sure, sure. All right. I'll go faster. Uh, so, uh, so since 1 minute, so I will just present the MRC criterion. So this is the criterion to assess the parameter transferability from calibration to validation, and we can see that we have a performance loss of about minus 25%. Conclusion. Certain aspects such as the research pattern selection, the quality of the input data, the selection of the proper, I mean, the calibration period and proper hierarchical models, the calibration method, and also the various optimized parameters is really important when doing some hierarchical models for better run of assessment, because the changes of one of these aspects may lead to different results and then different conclusions. So the outcome of these research may lead to a master of uncertainty associated with hierarchical models and a better assessment of the runoff. So for further questions, thank you very much for your attention. So we have the paper will be available soon, and we have full, a more extended version of this presentation, so that you can find that we've already shared. So